Alright, so welcome if you are joining us. Welcome. Oh, Donald's here already. Good to see you, bud. Feel free to say hi in the chat if you're joining us. Happy Thursday. We're going to get started right at about 2:05, so that is, look at my time, about 3-4 minutes, and then we will start the lesson. So if you're here, thanks for being on time. We'll get going in about 2 minutes. All right, looks like we have Marco. I do see you, Marco. I was grabbing water quickly before we got started. But thanks for saying hi 97 times. I appreciate your eagerness every day, Marco. And I'm being serious, not joking. Hey, Mr. Chu. How you doing, man? All right, what time do we got? 2:02, so about 2 more minutes and then we'll start. Thanks to those of you who are on time. Sorry for the short wait. Yeah, me too, Mr. Chu. I only had a few kids yesterday. We gotta... Attendance is not moving in a positively sloped direction. It's definitely a negative slope on attendance lately. Alright, I am going to get started on this lesson. I think anybody who joins us late can definitely kind of rewind and start from the beginning. I have no idea how you put that loading emoji, by the way, Marco. Nice work. Alright, I'm going to zoom in on the document a little bit, put it towards full screen. Today is all about slope, y-intercept, and working with the graphs. Basically, how do you take an equation that's in slope-intercept form and make a graph, or if they give you a graph, how can you turn that graph into an equation, find the equation to match it. Our big key terms here today, the first one that I'm going to go ahead and highlight here, the y-intercept is really the first thing we need to understand. That's going to be the point where your line crosses the y-axis. And why are you saying bruh, Marco? So, Marco, anything before this gets... Can you be live on Instagram? No, I don't really do the Instagram thing. Marco, if you got math questions, let me know. Otherwise, I'm going to focus in on the lesson at this point. Alright, so where you see my mouse now, the y-intercept, that's going to be the point where your line crosses with the y-axis. It's really going to be, always, it's going to be your value for y when the x is equal to 0. It's kind of the starting point for every one of these linear relationships. The slope is the other thing we need to know about every linear relationship. If the y-intercept tells you where you start at, the slope describes your rate of change. It describes how y and x move in relation to each other. So, for the very first problem today, you see here they're giving you two graphs, and for each of these linear graphs, straight line graphs, they're asking you to determine the y-intercept and the slope for those graphs. So the first one that we are going to take a look at here is this graph on the left. And the first thing they ask us is to find the y-intercept. And it's important to understand that the y-intercept is really going to be the point where this blue line here crosses with the y-axis, or where you see this red dot that I'm putting on the screen right now. And the coordinates for that red dot that I put on the screen, that's what they're looking for the y-intercept. And every point on a graph has an x and a y coordinate. And in this case, the blue line crosses with the y-axis or starts on the y-axis with a value of 3. And that means for us that the y value for the y-intercept was positive 3, and the y-intercept's x value is always going to be 0. An important thing to understand about my y-intercept is it really describes whatever y value this equation has when the x is set equal to 0. The other thing they want you to figure out is if it starts at a positive 3 value for y and an x value for 0, how does that relationship change? That's what slope describes for us. And so if I'm going to measure slope, I really need to pick out 2 data points on this graph. So the first data point I'm going to go ahead and mark is this one right here. Let that fade away for a second. So this point that we use for the y-intercept we can use to measure slope, and then I'm also going to follow this graph and I'm going to look for another time when the blue line hits the corner of a grid box. This right here I don't think would be a very good point where I put a red dot because it's not clearly on a y-axis grid box. I don't know, it's somewhere between 2 and 3. So instead of using those 2 points, I'm going to use this y-intercept, and then I see right here is another corner of a grid box, or we even could have used any of these other red dots you see that are kind of all on corners of grid boxes. I'm going to focus on these 2 right here. To get from one to the other, we need to travel down by 1 unit, and we need to travel right by 2 units. This line goes down by 1, right by 2, down by 1, right by 2. That tells me the slope is losing 1, going down by 1, which is a negative 1 for y, every time we move right by 2. So again, that's how we got to our slope of negative 1 over 2 right there. For the other graph, if you are watching the recording, you should pause this and come up with the y-intercept and the slope on your own. If you're with us live, I'm moving a little slowly. Hopefully you're ahead of us and starting to think about what is the y-intercept and the slope for the next one. For this blue line, again, every y-intercept will be where the blue line crosses with the y-axis. And in this case, right there where I've marked that red dot, this is where the y-intercept occurs for that graph. So in our case here, the y-intercept is going to have a value. The y value will be negative 1, and then the x value is going to be 0. Again, every y-intercept always has an x value of 0 because it's wherever the line crosses with the y-axis. In this case, it crosses at negative 1. Now, to measure our slope, we're going to take a second point. We have this data point already. I'm going to follow this blue line, and I'm looking for another corner of a grid box, something that makes the coordinates easy to work with. And I see right here, where I'll put another red dot. That's another nice data point to use to measure slope for this linear relationship. From this first data point, the y-intercept, to the second one, I have to climb up by 3 units, and I need to climb right by 4 units. So the rise is a plus 3. Dana, awesome to have you with us. And the run is a plus 4. So for this blue line, it's going up by 3 units. The y is gaining 3 every time it moves right by 4. So that gives us a slope of 3 over 4. 1 second there. And again, right there, that's kind of how we measure our slope of 3 over 4. One last key thing I'll note as you do these, this comes up on Khan Academy for a couple assignments this week. Whenever they move up to the right, you end up with a positive slope. Whenever the line moves down to the right, that means the y value is decreasing as x gets bigger, and that's why those have negative slopes whenever they move down towards the right. Hopefully that makes sense. We're ready to move on to problem 2. Before we get into problem 2, I'm going to make the whiteboard a little bit larger for a second to talk about the bottom key term here. This is also in your key terms on page 1 in the document. Slope-intercept form is one way to write an equation for every linear graph you run into. And the equation is built in this form, y equals mx plus b, where the y is solved or all by itself on the left side. And any linear equation that's in this y equals form, we call this slope-intercept form because this type of equation, the way it's written, automatically tells you the slope and the y-intercept if you know how to read it. Whatever number is multiplied with x, what I've put in green here, that's going to be m. That's going to be the slope. Mr. Neville would have used the term coefficient last year to determine or to describe the number that multiplies with x. So whatever the coefficient of x is, the m, that will represent your slope always. And whatever number is added or subtracted all by itself, the b, that represents your beginning point, or your y-intercept. So the first equation that we're given, well, the whole first problem, let me scroll down a little bit so you can read it. It says to identify the y-intercept and the slope. So it says identify the y-intercept and the slope for each equation shown below. And the first equation that we're dealing with here is this equation y equals 3x minus 2. So what I notice, it's in y equals form. If you take a look at my whiteboard, it's in that y equals mx plus b, that slope form. So if I want to find the y-intercept, that's always represented by the b, the number that's all by itself. Or in this case, our y-intercept is represented by that -2 right there. That's the b, the number that's all by itself. So that tells me my y-intercept, my value for y at the beginning when x is 0, is going to be -2. So I'm going to put in a 0, -2 for the y-intercept. In other words, if we were to put in a 0 for x, this whole 3x term would disappear, and the only thing we'd be left with is y needs to be equal to -2 if we make x equal to 0. The other piece is the slope. It describes how much y will grow by for every x, and in this case, y is actually going to shrink. It's going to lose 3 units for every single x. The slope is going to be -3 over 1, and I know that because the -3 is really in the m's position. It's the coefficient of x, the number that's multiplied with x, and that's how I know it's the slope. Let me shrink the whiteboard a little bit so we could read some of these better. Ooh. Alright, if you're at home, I would encourage you now to pause this video, try to do the next 3 on your own, and if you're with us live, hopefully you're kind of thinking about these in advance as I slowly work through each problem. So for the next one, our y-intercept, we're looking for the b, and in this case, our y-intercept is going to be that +5 that's all by itself right there. So that tells me my y-intercept is a positive y-intercept in this case, so I'm going to have 0 for x, and this time y is a positive y-intercept. It starts out with a y value of 5. And then what's tricky here, they didn't write a coefficient of x. The x is all by itself. And hopefully you recall from last year, if our x is all by itself, what they really mean is 1 times x there. If there's no coefficient of x, it really means we only have 1x, so that means our slope in this case is just going to be 1, or if we were to write that as a fraction, 1 over 1. That means every 1x here is also going to make y bigger by 1 unit. For the next one, a little tricky, and they'll do this to you on Khan Academy too. You will notice they swap the position of the slope term, which is this -4x, and the y-intercept. They listed the y-intercept first here. The y-intercept is always the b, the number that's the constant, regular number all by itself without an x term. So in this case, that 3 right there represents our y-intercept. So I'm going to go ahead and put a 0 for x and a 3 for y. If we were to go ahead and plug 0 in for x, if we eliminated that whole -4x term, then y would need a value of 3. The slope then, of course, is going to be the m. In this case, we see that m, the coefficient of x, is this -4, so our slope in this case is -4 over 1. And it also looked like for assignment 3 this week, which is very similar to problem 2, they throw some tricky ones at you where either the slope or the y-intercept might be 0, and then those equations look a little funny. Here, the last one, the equation is pretty simple. It just says y equals -4. And if it just says y equals -4, we don't even see an x here. And the reason for that, I'm going to do this a little backwards, is our slope was actually 0. If you do 0 times x, then the total mx term would disappear because 0 times any x would still be 0. So the only thing in this equation is b. Y is always equal to -4. Whether I make x 0 or any other number in the world, in this relationship, y is always equal to -4, and it never grows or shrinks, which is why the slope is 0. I hope that was helpful. If you've got questions, if things are unclear and you're live with us, definitely put them into the chat. Thank you to those of you who are live and those who are at home watching the recording after. We're going to keep moving into number 3. So, the big key to understand now when we're moving into number 3 in the rest of this document is all of these linear relationships have two key components, two key parts. They have a y-intercept wherever they start out at on the y-axis, and then the slope describes how steep or how quickly that line needs to move up or down as it leaves the y-axis. So for number 3 here, we're told to create a graph for both linear equations shown below by first identifying the y-intercept and slope, by second plotting a point for that y-intercept, and then number 3 we're going to use that slope to find other points on the graph. So our first job here is to identify the y-intercept and the slope. So for this graph, I'm going to be graphing y equals 2x minus 5. That's going to be the blue graph that I'm trying to make. And first I want to identify my y-intercept, and I'm going to go ahead and I'm going to circle that y-intercept right here. So for the blue graph, we have a y-intercept value of -5. This blue graph is going to have to start out with a y-intercept of -5, and then our slope is going to be that 2 over there. Our slope, give me 1 second to play with that. There we go. Our slope is right here. That's the 2. That's what's multiplied with our x. So here I have a y-intercept of -5, then a slope of 2. Keep that in mind as we now build our graph. I'm going to have to double click to open this drawing. And it's going to be a little slow. I didn't realize that. So bear with me. Because of all the recording device, this might be a little laggy as it loads up. Did better than I thought. Alright, so recall here for this drawing, our original equation was y equals 2x minus 5. You can kind of see it over there. And our y-intercept was -5. So the very first point I'm going to plot, this is step 2 on the question 3, I'm going to plot the y-intercept of -5, and that's going to go, oh, my whiteboard's in the way, isn't it? So now you can see I've plotted that y-intercept of -5. I also recall that the slope here, that slope was y equals 2x, so I need a slope of 2. And if the slope is going to be 2 over 1, right, our slope was 2, then that means here that I'm going to go up by 2 units every time I go right by 1 for this blue line. It's going to travel up 2, right 1, up 2, right 1, up 2, right 1. That's what a slope of 2 means. Y will gain 2 units every time x gains 1. Or if you recall, on the whiteboard we described slope, where you see my finger pointing in green, as rise over run. So I'm going to go up by 2 and right by 1. And then just to plot another point, I'm going to go ahead back to this point. Again, every time y gains 2 units, that's the result of x gaining 1. Or every time I go up 2 units on this graph, it needs to go right 1. You do not have to plot these lines. It can be, or the actual line itself. But the key is, you saw I clicked on the blue line and then I click on either dot on the end. So we'll try to highlight in there a little bit. If you see my mouse right over that dot, now I can go ahead and drag this line by clicking and holding. I can drag it wherever I'd like. That will probably take some practice. The big thing here is to be able to build the graphs. It's a lot easier, I think, on Khan Academy when you just click the couple dots, or same thing with IXL. So I'm going to keep moving on to this red one, but now you see that blue graph is complete. Y equals 2x minus 5. I plot the y-intercept of -5 first, and then I go ahead and I use that slope of 2, that 2x, to tell me to go up 2 and right 1, up 2 and right 1. Okay, for our second graph that we need to make, again, I'm going to follow the same process. First thing that I want to do is I want to identify what is the y-intercept for this graph. And in our case over here, the y-intercept is that +3 that's all by itself right there. So we have a y-intercept of +3. And then we also have, if you take a look at the slope, a slope of -3/2. So our slope is -3/2, and our y-intercept is +3. That's 0 and 3 I'm writing there. So I'm going to go ahead and open this drawing up now. And that will take a second as my computer's a little lagged. And I'm going to recall here now as I try to build this graph, I need a y-intercept of 0 and 3, right? That was that plus 3, and I need that slope of negative 3/2. So I'm going to go ahead and I'm going to plot this y-intercept of 0 and 3. It has a positive 3 for a y-intercept. So I'm going to drop the first red dot for this graph right on a y value of 3 or a y-intercept of 3. And then recall also that our slope was negative 3 over 2, which really meant that our y value, our y change, was going to lose 3 every time our x change was going to be 2. Or this is really rise over run. So I'm going to be traveling down by 3 units every time I go right by 2. Down by 3 and right by 2. And that should give me a line that has a nice solid slope of negative 3 over 2. So again, back to that y-intercept, down by 3, right by 2. And that's how I find the first new data point after the y-intercept. Again, down by 3, y loses 3. Then I need to go right by 2 because x gained 2 to cause y to lose 3. Now that you get those 3 dots, you see they fall in a straight line, and you can feel free to go ahead and try on your own to go ahead and draw a line or drag this line in a way that it goes through all 3 dots. A little hint on how I figured that out, I kind of used slope again. I started this guy, I went up by 3, left by 2, and I knew this would be another point, so that's where I put one corner of the line, and then I just drew it straight through the other 3 dots. It doesn't have to be perfect. Any line that looks like it does a good approximation of going through all those dots. Okay, and a quick little recap here before we move on to problem 4 and 5. Now I see for the blue one, I see it had a y-intercept of negative 5, and this graph's got a y-intercept of negative 5. It had a slope of 2. It's going up by 2 and over by 1. And then I also see for the red graph over there, it had a y-intercept of positive 3. And I see this graph with a positive 3 for the y-intercept now. And a slope of negative 3 over 2, meaning it will go down by 3 and right by 2 as it progresses. Hopefully that's clear. We are going to keep moving now on to problem 4 and problem 5. Problem 4 is almost the reverse of number 3. When you do Khan Academy this week, you'll see assignment 4 and 5 are very much like these. For assignment 4, you will have to build your own graph, and then for assignment 5, just like problem 4 here, they'll give you a graph and ask you to say what equation creates that linear graph. So if this is the reverse, recall to write any equation. They give you this y equals mx plus b here. And let me bring my whiteboard back into play for 1 second. For every equation that we want to write, we need to know 2 things. We need to know what is the slope, that will replace the m, and we need to know what is the y-intercept, that will replace the b. So for this first equation here, I need to go ahead for this blue line, and I want to first figure out the y-intercept. I think it's easier to find y-intercepts first. So in our case here, I follow this blue line, which I'm kind of highlighting now, and I look for where does the blue line cross with the y-axis, that vertical up and down axis. And I see right here, this pink dot I'm putting right on that 4 is where the blue line crosses with the y-axis. So that positive 4, a y value of 4 at the beginning when x is equal to 0, is our y-intercept. So I'm going to plug that y-intercept into the equation. I know my b value, my y-intercept starts at 4, and now the real question is, what is going to go in for m? What is the slope after it starts at a positive 4? To measure the slope, I'm going to need 2 data points. I'm going to use that y-intercept that we flagged already once. And I'm also going to take, turns out the x-intercept I see is right on the negative 2, so I'm not always going to use x and y-intercept together to get slope, but if they're right on corners, they're 2 great data points to use. So if I start here, over at the negative 2, and then try to get to the y-intercept, first I need to climb up, and then I need to climb right. Specifically, I need to climb from 0, right on the x-axis, up to a positive 4. So this needs to go up by 4 units. It gains, or it rises by 4 units. And to do that, it starts at -2, gets over to the y-axis, so it slides right, or moves right, by 2 units, by a +2 there. So if I rise by 4 and run by 2, that means my slope ratio is going to be 4/2. My slope will be equal to 4/2. But I need to simplify that. 4 divided by 2 just equals 2. So I'm going to simplify this slope all the way down from 4/2 to 2/1, and then simplify further just to a slope of 2, because that's what 4 divided by 2 gives me. So I'll plug in that slope of 2. You could put 2/1 times x, but it's more simplified to just write 2 times x, and you're more likely to see that on Khan Academy or IXL. If you are at home on your own, I would encourage you to now try to do that second graph, come up with the slope and the y-intercept and the whole equation on your own. And if you're with us live, hopefully you're already saying, Mr. Doherty, I know what the y-intercept is. I'm figuring out the slope and I'll get there before you. As I look at the second graph and I need to come up with an equation for it, the first thing that I need to do is I need to figure out where is this blue line crossing with the y-axis. That will represent my b, my y-intercept. And in this case, we see the blue line crosses with the y-axis right here, where the pink dot just went. It has a y value of -6 at the very beginning. When x is 0, at the start point, our y-intercept is -6. So if 0 and -6 are the coordinates for that y-intercept, I'm going to plug this -6 in for b as the y-intercept. If your y-intercept is negative, you could put it in there as a negative like that. Khan Academy actually marks that wrong, I figured out, and they want you to simplify further to just say -6, because that's the same thing as adding a -6. Now the second piece that I need to figure out is my slope, the m piece here. And so if I need to go find my slope, which I'll do in blue, the slope is going to be found by using 2 data points. I'll use this y-intercept as 1, and I'm going to look on this graph and try to find another nice corner. It's a little tough, it may be too zoomed out for you all to see. But I see, and if you're zoomed in on your own document, right here I put a blue dot, and then also right here I put this other blue dot, and right here at the -8, those are some other corners of grid boxes that would be decent to use. I'm going to go from the pink one, the y-intercept, to here, the last blue dot on my blue line. And to do that, I need to travel down, and I need to travel right. Specifically, I need to travel down by only 1 unit, and I need to travel right all the way over to the +4 from the y-axis. That's 4 units, 1, 2, 3, 4. So in this case, our slope, our m for this equation, is going to be -1 for the rise. The y value lost 1 as the x value gained 4. So our slope is going to be -1/4. It's fine to write the fraction that way as -1/4 if you really want to get fancy. There's a way to insert a fraction into Google Documents. I'm going to show you that, but again, it's totally fine to use the slash. If you hit insert and then equation, that helps you type equations. As you can see, I'm already in an equation, so they've grayed out that option. I'm instead going to just show the equation toolbar from view. And if I want to put a fraction in there, this menu right here, the math operations menu that I'm hovering over, if you click on that menu, the A/B inserts a fraction. And now I put the number on the top, a -1, and I use the left and the right arrow keys. If I hit right on my arrow, it brings me to the bottom of the fraction, and if I hit left, it kind of lets me work backwards through that fraction. So again, if you're in the equation tools, left and right arrow keys can help you be more exact. But again, totally fine by me if you just write -1/4x as your final answer. That's number 4. That's where I was hoping to get us today through the master's level problems. The last assignment for this week on Khan Academy, the 6th one, instead of giving you a graph and asking you to come up with the equation, the last Khan Academy assignment this week is a lot like number 5 today, the PhD problem. Instead of giving you a graph, they make it tougher by only telling you 2 data points that the line crosses through. And when they only give you 2 data points that the line crosses through, there's a couple challenges if I want to try to write an equation. We should know now, to write any linear equation, I need to figure out, number 1, what the y-intercept is, and number 2, what the slope is. But if they don't give me a visual graph, and neither data point has an x value of 0, I don't know what the y-intercept is here at the beginning. And if I don't know what the y-intercept is, my job is probably going to be first to find slope, and then slope can help me figure out what the y-intercept is. So again, to recap for this last problem, number 5, I need to write equations to match a line that goes through these 2 points. And I'm going to first measure the slope because I don't know what the y-intercept is yet. I don't have the benefit of looking on a graph. Alright, awesome, Mr. Chu, thanks for letting me know. Thanks for stopping in with us. So, for this one, we've got 1, 4, and 2, 2 as our 2 data points that the line passes through. I'm going to use my whiteboard quite a bit here, so I'm going to make that a little larger. And I'm going to write down those 2 data points. This line goes through 1 and 4, and it also goes through 2 and 2. They list these as ordered pairs, and it's important to remember that an ordered pair is listed as x first, and then y. And it's also important to remember for slope, slope measures our y change divided by our x change. So if I'm measuring slope with these 2 data points, the first thing I'm going to analyze is what happens to the y value, so that way I remember to put the y change up top of the fraction. Kind of my job, Marco, to know the stuff. That's just what we're working on, and I've done it for a few years. You're going to have this down too pretty soon, bud. So in this case, the y value starts at +4, and then it travels to a value of +2. So the y value from the first point to the second point actually decreases by 2 units. To get from 4 to 2, I would need to subtract 2. So my y change here is going to be a -2. I've lost 2 values, or 2 units on y. And during that time, the x value went from +1 to +2. That increased for x. X just got bigger, even though y was getting smaller. Specifically, how much bigger? X got bigger from 1 to 2. It grew by +1, or +1 unit. So this is how I figure out the slope for this first equation. When I look at these 2 data points, they tell me the y value will lose 2 units each time the x value will gain 1 unit. So that gives me a slope of -2 over 1. Now we figured out half of the thing we need for our equation. To write any linear equation, you need to know 2 things, the slope and the y-intercept, and we now know the slope. To find the y-intercept, there's 2 methods to think about. First off, recall that the y-intercept is going to be the value for y when x is 0. And I know here that when x grows by 1, when it goes from 1 to 2, the y value loses 2 units. So I'm going to put this onto my whiteboard, and I'm going to try to think backwards for a second. If I had these 2 points in a table, at the beginning when x is 1, y is 4, and then when x is 2, y is 2, the y-intercept really says, what is the y value when x is 0? And I can use the pattern here. I know every time that x gets bigger by 1, y is going to lose 2 units. That's what the slope told me. So if I go backwards, if x loses 1, that means y is actually going to gain 2. Every time I go back by 1 for x from 2 to 1, the y gets 2 bigger. So if I add 2, if I work backwards, I can actually use the pattern in the table to realize if it was 1 and 4, and then 2 and 2 and following a straight line relationship, back in time when it was x is 0, the y must have been 6, because it had to be 2 bigger than here. That might be a bit confusing. There's a more straightforward method to find any y-intercept if you know slope and 1 point. I'm going to slow that as well. So I think the y-intercept here is 6. But to check that out, I'm going to try a different method. I have y equals mx plus b. That's my equation that works for every line in the world. I know the m already. I know that the m is, in this case, -2. So I know for this equation it needs to look like y equals -2x plus whatever the y-intercept is, and I think that's probably 6. If I want to figure out what that y-intercept is, I can plug in any data point from the line for x and y, and then the only value left or variable left would be b. So in this case, I'm going to choose to plug in the first data point. The first data point says this line, this equation, needs to work when x is 1 and y is 4. So I'm going to go ahead and plug that 1 and 4 data point in. I'm going to replace y with 4. I'm going to replace x with 1 and keep the rest of the equation the same. So I took that 1 and 4 data point and I just plugged it into the equation. I replaced y with 4. I replaced x with 1. Now the only variable left in the equation is b, so I'm just going to solve. 4 equals negative 2 plus b after I do the negative 2 times 1. I want the b to be all by itself on the right side of the equation, so I'm going to add 2 to both sides of this equation. By adding 2, I cancel out the negative 2. That's the inverse operation that got b all by itself. I also had to add 2 over here. 4 plus 2 tells me what we had expected in the beginning. The y-intercept needs to be 6 if you have a slope of negative 2 and it's going through these data points. So again, as we touched base with Marco on Tuesday, the PhD ones are reserved for tough problems. And if they only give you 2 data points and ask you to find your slope, it's a bit of work. 2-step process. Number 1, measure the slope. Number 2, use the slope to find the y-intercept. We're going to transition now to that last problem on number 5. A very similar problem, just a different type of linear equation. This time the line is going to pass through 3 and negative 8. And it's also going to pass through 6 and negative 4. So if you're at home, I'd encourage you to pause this. If you're live with us, I'm going to just keep it moving because the video is running a bit long. 3 and negative 8, and then it travels to 6 and negative 4. I don't know the y-intercept, I don't know the slope, I need to figure out both here. And if I don't know both the y-intercept and the slope, the first thing I figure out is the slope. Slope is going to measure y change compared to x change. So for these 2 data points, I'm going to first look at how much does the y change by. The y value goes from negative 8 to negative 4. That's actually gaining, that's growing, by 4 units. I got 4 units closer to 0, so I got 4 units bigger when I go from negative 8 to negative 4. So the y growth is a plus 4. And the x growth, x goes from 3 to 6. If x goes from 3 to 6, that means it's gained units. Specifically, it's gained 3 units. So that helps me get a slope of positive 4 over positive 3. That's half of my equation. That's the m in my mx plus b. So I know my slope now is 4 over 3. And now the only thing I need to figure out is what is the b? What is that y-intercept going to be? Again, I want to figure out, I now know the slope is 4 over 3, so 4 over 3 goes in for m, that's the m piece. And I want to be able to figure out what is the y-intercept. Angelica, thanks for joining us. I would encourage you to kind of start at the very beginning of the video. Angelica, number 5 is kind of just an overly complicated problem we're doing to mess around at the end. Hopefully the beginning ones make some sense, and awesome to have you joining us, Angelica. Alright, so if I have that plus b now, y equals 4/3 x plus b, I could do a couple things here. One of them is to plug it back into that y equals mx plus b equation, then plug in 3 and negative 8 and solve. Or I could follow the pattern. I know that the y-intercept is going to be the y value when x is 0, right? And if I'm looking on this whiteboard, which I'll make a little larger, to turn that tool up. I know here when x was 3, y was negative 8. Then when x grew to 6, y grew to negative 4. That means every time x gains 3, y gains 4. And a y-intercept says I need to work back or figure out when x was 0, what value did y have? And here I see a nice little pattern. I could follow this pattern backwards, from 6 to 3, from 3 to 0. So if I go from negative 4 to negative 8, if I lose 4, I need to lose 4 more again. It's going to be negative 12. So if you see that pattern, that slope rate of change, and numbers make a bunch of sense to you, you may be able to just use those numbers to kind of work backwards and figure out, hey, what y value would this pattern have when x is 0? If that seems too complicated, and it seems a little complicated to me, I like the tried and true method. If I don't know my y-intercept, so let me make this whiteboard smaller again. If I do not know the y-intercept, but I know the slope, and I know one point, I can use my y equals mx plus b formula to figure out what the b needs to be. Here I know the slope is 4/3, so I'm going to write y equals 4/3 x plus b, because I already know the m. And I can take either data point the line passes through and plug those in. I'm going to choose to use, in this case, I'm going to choose to use that first data point, and I'm going to be plugging in a 3 for x, and I'm going to be plugging in a negative 8 for y. So that 3 and that negative 8 are going to come into this whiteboard. The y gets replaced by negative 8, the x gets replaced by 3, and when I substitute the y and the x out, the only variable left is b. Now I can solve this equation for the y-intercept, figure out what it needs to be. So I'm going to go ahead, I'm going to do 4 over 3 times 3. 4 times 3 is 12, and 12 divided by 3 is 4. Or even simpler, you see the times by 3 and the divide by 3 kind of just cancel each other out and leave us with 4. So I have negative 8 is equal to 4 plus b. My b is on the right side of the equation. I want to get that all by itself, so I'm going to subtract 4 to cancel out the 4 that's on the right side of that equation here. By subtracting 4, now I have b equals whatever negative 8 minus 4 is. If I combine two negatives, I add them up, and I keep them negative. Negative 8 and negative 4 gives me negative 12. And if you recall earlier, based on some of our other work using the pattern, we also believed the y-intercept was supposed to be negative 12. As I come back to that document, give me 1 second. So we have a y-intercept of negative 12, and that's going to go just into the equation as saying subtract 12. So like I said, I think that fifth one is very challenging. It's the last Khan Academy assignment this week. If you get stuck on that, please feel free to send me emails. I'm happy to jump on Google Hangouts with you and work through anything for Khan Academy this week. Thank you for those of you who showed up. If you have any questions, put them in the chat box right now. Otherwise, if you've got math questions, please feel free to send me emails, and I'm happy to jump on Google Hangouts or Zoom, whatever works best for you, and we can work through some of this one-on-one. Alright, cool. Thanks for watching to the end. We will be together tomorrow at 2 o'clock to be doing Kahoot, and the Kahoot will be focused on a lot of the math that you see on Khan Academy this week. Thanks, Marco. I'm a fan of you too, buddy.